Hi everyone, my name is Devang and I welcome you back to this course. In this particular video, we will be talking about three things, which is best case, worst case, and average case analysis. Like in the previous part of the video, we discussed about order of growth. If you haven't seen that part of the video, please make sure that you watch this first, then you will be able to understand what I'm doing here. And then after that, we will be seeing some of the asymptotic notations. Before that, let's know about the Launchpad section of the Newton School. Launchpad is basically an initiative which is taken up by the Newton School to make India the developer powerhouse of the world. If you want to learn anything for free, just go on to this Launchpad section and just click on this button, start now, for free, and you will learn anything for free. You will also get the certificate of completion. We have best instructors and etc. And let's say that you want to learn more and you want an assured placement, so you just go to this Newton School website, and we offer basically courses of 6 months. From here you can learn anything from scratch and you do not have to pay anything until you are placed. Newton School has a tie-up with approximately 300 plus companies, from wherein you can get an assured placement of a package around 5 lakh to 40 lakh CTC. So make sure that you go to the website, like you can see here many companies are tie-up with that, and you can also review the testimony, like what the students say about that. Okay, so let's dive into the course, dive into the lecture right now. Just a minute. Yeah, so first of all, we have seen the order of growth. Like what was the order of growth? Order of growth was like n square, n log n, right? We discussed this in the previous part of the video. Now let me discuss something interesting with you. Let's say that I have written a code int main, and first of all input a function int n, cin n. Then I'm gonna say that call the function named as function for n. Let's say I do this, and here I have a function which is void function. This void is basically return type of the function. This defines return type of the function. Here can come anything, like here it can come int, anything like if I do this and I say int n, and then I do if n modulo 2 equal to 0, return, else for int I is equals to 0, I is less than n, and I plus plus cout I. Okay, yeah, so let's analyze what this function, like how many times this function will run, because we have learned in the earlier videos as well that we calculate how many times. Let's think how many times. Let's say I pass on n is equals to 1. First of all, n is equals to 1. So like n modulo 2 is not equal to 0 because this represents the even one. N is 1 is not even, so this will not work. Return means go back. So this will not work, and this loop will run. So 0 will be printed on the screen. Now I say n is equals to 2. When I say n is equals to 2, this is the even number, and a return function will be return will be executed, and we will come out of the this particular function, and nothing will be done. Let's say that I send n is equals to 55, which is an odd number. So this loop will particularly run 54 times, and 0 to 54 numbers will be printed on the screen. Now say that I send n is equals to 1064. Sorry, this is particularly not 1064. This is 1,64,000 is sent, and let's say that this function is called over that. But particularly this is an even number. So this loop will not run at all, and we will get no output on the screen. Let's say that we do n is equals to 3. So this loop will run for 3 times. Okay. Now you can see that when n was 1, this loop was running for 1 time. When n was 2, this loop was not running at all. When n was 3, this loop was running for 3 times. When there was 4, this was not running at all. So this means that when my odd number comes, the loop runs for odd minus one number of times, like odd minus one number of times the output comes. Basically the loop runs n times, and when I have an even function, even number, my loop runs only for one time, only for, oh sorry, no time, like only for one time. No, like I can say that it does not runs at all. My loop does not runs at all. So let me define the best case and worst case for you here, like best case and worst case. Worst case for you, the best case would be the loop not running at all. Why I am saying this? Because I am thinking in terms of time complexity, like how much time it will take, So for me, better one is who takes less number of time, who take less amount of time. For me, that is the better one. I think it is a better one. And this even one, when even one will come, loop will not run, and my function will be completed in no amount of time, and I will be more than happy enough. But when the odd comes, when the odd number comes, it will run n times. So this can become our worst case. This can become our worst case. Not that kind of worst case, but this can come in the category of worst case or average case. Can we say that? Basically, what do I mean by best case, worst case and average case? Best case means constant work. Best case means constant work. Like I am sending the number. My best case means the function or the particular program that I have made is doing a constant amount of work. Like it is not doing some kind of extra work, or let's say it is doing an amount of work. No, basically constant work, like not big O, we have not discovered it yet. Let's say that around one time loops run, 2 time loops run, 10 time loops run, but constant. It would be my best case. Best case would be constant, like loop is not running at all, it is a constant one. So that would be my best case. Worst case would be the worst input time. What does that mean? It means like for the biggest input, or for the most different input, like most like for the, like if you have a function and for which input it would run at most, like it would run maximum number of times. That is my worst case. And the average case is between the best case and the worst case. Like average case is this is not possible that you have made a function and only even number will come to you and your time complexity will reduce and you will always get a best case. This is not the case. This is also not the case that you will always get odd numbers and your loop has to run. It is somewhat around average case, like sometimes you will get a small odd number, or you will sometimes get even number. So average case is considering that. These are basically three cases in which we discuss about any function. We discuss about these. We discuss any function in terms of these three cases, like best case, worst case and average case. Okay, now let me take you to the another one thing, like let's say that we have a function and this is our function, not function, like this is our program. For int I is equals to 0, I is less than n, I plus plus. I will kind of do some work. For not here, does not the loop ends over here. For int j is equals to 0 and j is less than m and j plus plus. Do some work here. So in the best case, my n would be 0. This thing would not run at all. When n is small. Let's say that n is some number, n is some given number, and m is small. Basically in this, n and m are given to us. These things are given to us. Okay, and like let's say that n is a number and m is also a number, and m is smaller than n. N is small. Just a minute. Like n is greater than n and m is very small as compared to n. So this function would approximately run for n times. We can consider n time, but n into, basically this would run for n into m times. But if m is so small then as compared to n, we can approximately say that this function would run approximately n times. Okay. If m is equivalent to n, if m is equals to n, then this function would run n into n is equals to n square times. So this is our worst case. This is our worst case, that the function would run for n square times, and it would only run for one time, or you can say that it only runs for one time is our best case, and average case is in between them. Like it could be n, it could be m, the average case is in between them. So we can just plot a line like this is our worst case, this is our best case, and this is in particular our average case. We can say this thing. Let me just check that if the video is recording. Yes. Okay. So this thing we have to keep in mind, like how the functions are analyzed: best case, worst case, and average case. Now when you are designing a particular problem or particular function, we are always interested in worst case. We are always interested in worst case. Why? Because this thing, if we somehow handle this case, if we somehow handle the worst case, the best case and the average case would be automatically handled. Like if I do some work upon this part of the line, or this part of my program would be automatically handled. But let's say that I am not that kind of a person that thinks about the worst case, and I always think about my best case. So in my best case, if I do some implication on it or some work on best case, it might create a problem on average case or the worst case. If I do some work upon average case, it might create a problem on worst case, but it will not create problem on the best case. So basically what I'm trying to achieve is that if I do something for the worst case, the previous generations or the previous functions or the previous one of will be always optimized if I do optimization on my worst case. So that's why I will always interested in the worst case. So basically now we are clear of the terms, like what are the best case and what is the average case and what is the worst case. I want to you know that average case is not easy to calculate. It requires a tough mathematical calculations. It is you can calculate this, but it requires some of the tough mathematical calculations. You can always search about that, but it is not but we do not have an interest in this part of, we do not always are interested in the average case. But in some functions, like we have some function in which we consider average case. We will talk about these in the later videos when we will see some of the functions, but let's just focus on the worst case, because we are always interested in the worst case. So now we are clear of that terms. Now let's understand like what is asymptotic notations. To understand this, I will take you back to some of the things, such as let's say that this is my function f of x is equals to x square plus 2x plus 3. What does this function means to you? This things f of x means my function f represents x, or my x is a function of some y, like you can say that y is equals to f of x. You can say that, right? Basically x is represented here. My function is taking input as parameters x, and it is giving my this output. Like we would be having order of growth as n square, order of growth as n cube, order of growth as n4, order of growth as n log n. But how do we represent this? Like how do we represent this, like in some kind of a function? Like in paper we can say that n square, but how do we exactly represent this kind of a complexities in terms of some of the functions? Like I want to say that my function this is equals to n square. Like I want to say g of n is equals to dash of n square. I want to make a function which represents my asymptotic notations. So let's understand the fancy definition of asymptotic notations. Asymptotic notations are basically way to represent my growth. to represent my order of growth. My order of growth in some function. Order of growth in terms of some function. In terms of some function. Like here you can also see that if I write y is equals to f of x, so y is represented in terms of x. Basically this we want to achieve in the asymptotic notations. So before proceeding any further, we should like to know that there are three major asymptotic notations. Basically there are many asymptotic notations, but majorly there are three. One is big O, then we have big theta, or you can say that theta, and an omega, or big omega, you can say that. We have also small omega and all kind of that, but we will not go into that much stuff because we are only required this much amount of time, this much amount of things. Basically we can also classify this. We have three: big O, big theta, and omega. These three notations we have, and we want to represent our function in this terms. I think that the things are getting clearer to you now. So first of all, we will discover big O notation. First of all, we will consider big O notation. Let's understand a very formal definition of that. Big O notation always gives an upper bound of a function f of n to within a constant factor, and this is basically in particular the mathematical representation of that. Let's understand in the more easy manner. Big O always represents an upper bound or below that. Like big O means the exact or lower. It means that it provides an upper bound for a function. I request you to do not mix it with worst case, best case, and average case, because in big O we can also have best case, worst case, and average case. It is basically the way of representation of our program. So it provides an upper bound for my function. If I write big O of n square, if I write my function is equals to big O of n square, so it means that either my function would have complexity of n square or less than that. Like this is the upper bound. If I say, if I draw something like this, okay, just give me a minute. If I draw something like this, like there is one layer 1, this is layer 2, this is layer 3, and this is my ground level. So level 1 is my big O1. So it ensures that either there will be no levels below that, or this will be my time complexity, or like there will be the lower time complexities. बेसिकली मैं कहना क्या चाह रहा हूँ, बिग O ऑफ n स्क्वायर का मतलब है कि या तो यही टाइम कॉम्प्लेक्सिटी होगी इसकी, लाइक दिस वुड बी द टाइम कॉम्प्लेक्सिटी, और बिलो देन दिस. If I write big O of n square, it covers n square by 100, and 1. It covers all these things. All these things would be considered in big O of n square, like n square by 2, n square by 3, n by 1, n by 2. All things would be covered in this kind of complexity. Okay. Now let's discuss about another time complexity, which is big theta. This represents exact bound for my function. This represents exact bound for my function. Now what do I mean by exact bound? Let's understand the basic definition of this. Big theta notation gives the bound of a function to within a constant factor. This will represent exact bound. If I write my complexity is theta of n, it means like in the whole universe this will be the constant one, n only. Like if I say that this is the complexity, this is the complexity, there is nothing in here, nothing in here, only this is my complexity. Like if I say theta of n, it means that it is n only. This is my exact bound, not lower than this, not upper than this. Okay. The third one is big omega. We basically do not use this one. It means lower bound. What do a lower bound mean? If I write big omega of n, it means that either my time complexity can be this, or it can be in the upper part of the graph or upper region. Like if I write big omega of, my time complexity can be n square, n cube, n power n, etc. But it would be never less than this. Okay, so this kind of function is most you can say that most least used. Let's read the that of the definition. So okay, the big omega function notation gives the lower bound of a function within a constant factor. Let's now summarize what we have read. We have read that we have three functions basically. Big O, which gives upper bound of our function. It means that if I say that my function is big O of n, either it will be this or this. If I say that my function is theta, it represents exact bound of my function. It represents always the exact bound of my function. It means that my time complexity would be exactly this. If I say omega, it represents the lower bound of my function, and either my time complexity would be this or upper than this. So let's say that you are in some sort of a company and you say that, hey, my program runs in big omega of n time complexity. What does it implies? It implies that either your function would run n times, or it would be having n time complexity, or n square time complexity, or n cube time complexity, or n power n time complexity. you are giving an ambiguous one time complexity. Now let's say that you just give your answer in this theta terms. Theta is a very good one because you are giving an exact amount, theta n. You are saying that, hey, nothing matters in the universe, my complexity would be theta of n. Exactly. So this kind is using various of the functions. And then we have big O, the best and the mostly used time complexity, the asymptotic notation, which is big O of n. Big O of n implies that I am working on upper bound only. I am working on worst case only. Actually, this is considered to be as worst case by many of the candidates, but it does not represent worst case. We can represent my best case in terms of big O analysis. Let's say that my best case is big O of n. It means that it will run n times for a shorter input, or the best case. Like for the best case, my complexity would be n or less than this. For the worst case, we can do any, like in all this function we could have best, worst, average, best, worst, average, best, worst, average. We can have all these three in these particular functions, but mostly this is used because it represents an upper bound. You are saying that, hey, either my complexity would be this or lower than that. So that's why this is mostly used. I think that you are getting a hint like what are the time complexities and how we calculate them. Let me just summarize this video, and then we will proceed to what are some of the, we will calculate some of the complexities of some functions. So before proceeding to that, let me just make sure that you are getting a hint of what we are doing in this particular video. Firstly, we saw about cases. So in particular, there are three cases: best case, worst case, and an average case. Okay, and when we saw and then we saw particular notations. So we are seeing that there are three kind of notations basically. Big O, which can have these both three analysis. Then we would having omega, it would also have three analysis, and it could also have theta, it could also have these three analysis. The most one is used worst case here, and most one is used omega here. So this is particular summary what we did in so far in the video, and I think that things are clearer to you. Let's understand one code. Okay, let me take an example. For int I is equals to 0, I is less than, okay, before proceeding any further, we will always talk about big O of n from now on. Big O of n, we will always talk about basically big O notation, and in the big O notation in particular we will talk about big O worst case analysis we will do. because this is a mostly used, and this will give you an accurate assumption or accurate answer of your function. Okay, so we'll be always doing a worst case analysis in terms of, let me just write down here, worst case analysis in terms of big O notation. So now on, and in many sites that you just search on the Google and solve and get your answer, this would be used for the time complexity as well as the space complexity. Okay, so let me just rub this one. Okay, just a minute. Perfect. Okay, so I is less than n and I plus plus, and I'm gonna say that do some work here, do some work. So can you tell me what would be the time complexity of this function in terms of big O and worst case analysis? I would recommend to pause your video over here and think about like what would be the time complexity of this function. Okay, so I'm hoping that you have paused the video and now you are you have got a solution. Just match your solution if it doesn't matches. So the time complexity will be of this function would be big O of n. At max it would run n time, and big O of represent that this is the exact bound of the function. Okay, now let's do another question which states that for int I is equals to 0, I is less than n, I plus plus, then here we will do some work. You have seen this question actually. For int I is equals to 0, I is less than m. Okay, let's do some variation. Here I can write I is less than n and I plus plus and do some work over here. So in this particular case, my time complexity would be big O of n square, because at most this function would run for n time. Also this function would run for n times. Now n into n, because for particular n this would run n times, so n into n becomes n square. So my time complexity would be big O of n square. Okay, so now we are we are clear of many various things like what is the time complexity and how do we basically represent in terms of big O notations and also the worst case analysis. So I will end the video here, and if you have any doubt, make sure that you just comment your doubt and I will be more happy to answer your doubts. And in the next part of the video we will do some questions on time complexity and we will see the space complexity part as well. Then we will proceed on the other data structures such as strings and all that. So this was the important part of the video. I hope that you understood the basic crux, like what we wanted to basically learn about the time complexity and notations. So thank you, bye bye.